everyone, we are seniors from SIMOV Juan de Dios Batis at the IPN. So here's the thing, as people get older, everyday tasks like reaching for a glass or moving things around become a real struggle due to a loss of strength and mobility. To tackle this, our team built a project called the Assistive Robotic System with a remote control for supporting elderly people in object manipulation, or as we like to call it, SIMOV. Basically, we designed a mobile robot with a built-in mechanical arm that helps older adults grab and move objects completely wirelessly. Before starting the project, we researched the main difficulties that every people face at home. We found that many accidents happen when they try to reach objects that are too high, too low, or too far away. Something as simple as pick up a bottle, a remote control, or a medicine container can become a difficult and sometimes even dangerous. We also looked at existing assistive technologies and noticed that many commercial solutions are expensive or require complex installations. That inspired us to develop a more accessible alternative that could be built using the knowledge and resources available to the students. Our goal was not only to create a functional robot, but also to demonstrate that engineering projects can have a direct positive impact on people's quality of life. Another important aspect was making the robot easy to use. Since our target users are older adults, we want to control systems that feel familiar and simple. Through the development process, we constantly ask ourselves how we could make every interaction more comfortable and intuitive. This user-centered approach gives many of our design decisions from the beginning.
To bring this to life, we have to combine everything that we have learned in the school. We use physics and maths to figure the robot's balance and precise angles, so it wouldn't tip over. We spent over hours on Autodesk Inventor designing the whole thing 3D and simulating how the pieces could fit together. Once the digital model was perfect, we fabricated the body using 3D printers with PLA and ABS plastics. This kept the robot super lightweight, but tough enough to handle daily use. During the design stage, we created multiple versions of the robot before choosing the final model. Every component had to be carefully positioned to ensure stability and proper weight distribution. Even small changes in the location of the batteries or motors could affect the robot performance. Using Autodesk Inventor allowed us to visualize it to complete the assembly before manufacturing any parts. This helped us detect potential issues early and saved both time and materials. We were able to verify currents, dimensions, and movement range of the robotic arm through simulations. Once the design was finalized, we manufactured the components using additive manufacturing techniques. The use of 3D printing gave us the flexibility to quickly produce prototypes and make modifications whenever necessary. This process taught us how modern manufacturing technologies can accelerate product development while reducing costs. Additionally, we learned the importance of precision in engineering. A difference of just a few millimeters could prevent components from fitting together correctly. The experience helped us understand how critical planning and attention to detail are in real engineering projects.
Real magic happens behind the scenes with the electronics and the code. We build custom circuits to handle the power and make sure the motors were all born out. Then we programmed the microcontrollers to smoothly coordinate the motors, the arm, the base at the same time. But the coolest part is how to drive it. We set up a stable Bluetooth connection so users can control the entire robot using a standard wireless and can controller. It's super intuitive and easy for an older person to use. Developing the electronic system requires extensive testing and troubleshooting. Each motor had different power requirements, so we needed to carefully select the appropriate drivers and protection components. Safety was always a priority because we wanted the system to operate reliable under different conditions. Programming the robots involved creating routines that could coordinate multiple actions simultaneously. The ARM and mobile platform had their response smoothly to user commands without interference with one another. Achieving this synchronization requires numerous adjustments and repeats the sensations. Communication between the controller and the robot was another important challenge. We evaluate different wireless options and ultimately select Bluetooth because it offered a good balance between simplicity, reliability, and cost. Once the connections was established, we focused on minimizing delays and ensuring responsible control. Throughout this progress, we strengthened our programming skills and gained practical experience. With embedded systems, we learned that successful automation depends not only on hardware design but also on different software development and system integration.
Trust me, it wasn't an easy ride. We hit plenty of bumps along the way. At first, the arm was shaking crazy fast, so we had to tweak the code to smooth out the movements. And then the motors start drawing too much power and crashing the system, which we fixed by adding flighting capacitors to steady the voltage. This project pushed us way past textbooks. It forced us to think on our feet, manage our time under pressure, and learn what real teamwork and engineering problem solving actually feel like. One of the biggest lessons we learned was that engineering projects rarely work perfectly on the first attempt. Many times we encountered unexpected problems that required us to stop, analyze the situation, and find creative solutions. These moments were sometimes frustrating, but they also become valuable learning opportunities. For example, when the robotic arm moved too abruptly, we realized that the user was not only mechanical, but also relied to the control algorithm. By adjusting the programming parameters and testing different configurations, we were able to significantly improve the movement quietly. Another challenge involved managing power consumption, since multiple motors could operate at the same time. Electrical stability became essential. We spent considerable time measuring voltage, monitoring current consumption, and improving the circuit design to warrant reliable performance. Beyond the technical aspect, this project improved our communication and collaboration skills. We learned how to divide responsibilities, share ideas, and support one another when difficulties appear. So those experiences are just as important as the technical knowledge we gained.
In the end, we totally nailed our goals. The system works great and it completely closed the gap between high school theory and hands-on practice. Certain room to grow, like improving battery life of lifting heavy loads, but we proved that mechatronics can ingeniously make life better and safer for the elderly. This both experience was incredibly rewarding for all of us. Through this project, we discovered how engineering can be used to solve real-world problems. Building a robot is not only about technology. It is also about understanding people's needs and design solutions can improve their daily lives. Successful completion of SIMOV represents the result of months of planning, design, manufacturing, programming, and testing. Every member of the team contributed unique skills and ideas that helped transform an original concept into a functional prototype. Looking ahead, we can imagine several future improvements. For example, the robot could incorporate voice commands, obstacle detection sensors, or even artificial intelligence, features to increase autonomy. These additions could make the system even more useful for elderly users and caregivers. Finally, this project reconfirmed our passion for science, technology, engineering, and mathematics.